Hey folks, welcome back. In this video, we will be talking about Python collections module. So Python collections module provides additional data structures over built-in data types like list, dict, set, and tuple. So let's look at the data structures provided by collections module. So named tuple, deque, ChainMap, counter, order dict, default dict, user list, and user string. So let's start with named tuple. So it's a factory function for creating tuple subclasses with name fields. So let's look at the code for that. So here we have the named tuple. So we can access the tuple elements using names and also using indexes. So it's efficient and convenient to use to create simple classes using named tuple. So let's look at the simple code for that. Let me copy this code to playground. Let's paste it. So let's look at the code now. So now at line number 1, we have import statement from collections import named tuple. So in line number 3, we are creating a point class by using named tuple. So the class name is point, and this is the attribute x and attribute y. So this is the simple class. So now we created point, and we need to use that point class to create point object. So that is p1 equals to 1 comma 2. So this is how we use named tuple. So we just need to give named tuple. This is a function, and then the first parameter is class name, and the second parameter is a list of attributes. So let's use print statement to print p1, and let's run it python playground.py. So here we can see that it's a point class, I mean the point object, and x equals to 1, y equals to 2. So let me clear this out and go here, and let's print attributes, print p1.x comma p1.y. Okay, let me use f notation for this. X equals to y equals to. Okay, so let's save it and go to playground, and I mean terminal, and run it python playground.py. So now we can see that we have x equals to 1 and y equals to 2. So we can able to access that using dot notation. So whatever the value we give at first position, that assigns to the first element, whatever the name that we defined in a second parameter of a named tuple while creating it. So when we use p1.y, we get number 2. So similarly, we can also able to access using one more way, that is print p1 of 0, that is 0th index, and then p1 of y, oh sorry, p1 of 1. So that is first position of the tuple. So we can able to access both using names and what we call indexes. So let me run it python playground.py. So here we can see that we got 1 and 2. So that's how we can use the named tuple to create the simple class objects and access that using named attributes and indexes as well. So that's how we use the named tuple. Deque is a list-like data structure that supports operations on both the sides, and it is faster than list. So let's look at this diagram. So here we can do the operations from the front side and operations from the right side, that is from the left and from the right. So we can delete and insert the elements on both the sides. So let's look at one by one. So it's faster than list and supports operations on both ends. So we already know that. And so this is how we import the queue from the collections and create object for it. So these are the methods that we have on queues. So we can perform all these append operations, adding elements to the deque and removing elements from the deque. And we can also do the other operations like copy, count, finding index, and reversing it and rotating a number of elements and finding maximum length of the deque. So let's look at one by one. So before that, let's copy this code to playground and work on the methods of deque. So let me copy this to playground and paste it. Let's print deque. Oops, we need to use q. Okay, maybe that's a spelling mistake. Yeah. So let's go to playground and run. Oh, Python playground. So now we can see that we have a deque object here. So now what we need to do, so let's perform the operations on deque. So now we have only three elements, so we need to add one more element. So let's go here and start with this append method. So let's copy this append and add. Oops, I will add q dot append John and run it. So now we can see that John is appended at the right side. So let's say we want to append the same element on the left side, then we just need to do append left. So append left. Once we do that, let's go to playground, clear this out and run it again. So now we can see that the element John is appended on the left side. So that's how we do when we do append. So it appends on the right side. When we do append left, it appends on the left side. So that's how we do appending on right and left. Let's look at the insert. So let's say we want to insert the element at certain index, and then we just use insert. So let's go here and use that insert. Oops, what is the typo? So insert this element at index. So let's say I want to insert at index position 1, and then let's insert that. So once we do this, when we use this insert, this is the index number. The first parameter is index, and then the second parameter is the element. So let's run it. Clear this out and run it. So now we can see that at index number 1, we have John. So that's how we insert the element at a specific position. So let's go back to readme and let's look at extend. So when we want to add multiple items to the right, and then we just use extend and then followed by an iterable element, that is list, tuple, set, etc. So let's go to playground. So let's use extend, and now we need to use we need to give iterable element here. So let's do 1, 2, 3, 4. So when we do this, it just appends this all these elements on the right side. That's because we are just using append, sorry, extend. So let's run it, clear this out and run Python playground. So now we can see that we got 4 more elements on the right side. So that's how we add multiple elements using extend method. So let's look at extend left. Let me run it again. So when we use extend left, so all the elements will be added at left side. So now here we can see that we got all the elements added on the left side, but in a reverse order. So first it adds 1, and then it adds 2, and then it adds 3, and then it adds 4. So that's why we can we see a reverse order here. So that's how we use extend left. Okay, so there. Okay, now we done with all adding methods, and let's look at the removing methods. So let's clear this out. So let's say we want to remove an element from the right side, and then we use pop. So let's go here and just replace this method with pop, and then we don't need to do anything. When we do just do pop, so it just deletes the element and it returns the item. So item equals to that, and then deque. After that, let's add one more print statement and add item. Let's save this. So now we have 3 elements, that is apple, banana, and 500. So when we do pop, so it just removes 500 and it should return back. So let's run it, Python playground. Now we can see that it removed the 500, that is the last element from the queue, and so we can see that the returned element here on stored on item variable. So that's how we use pop. Let's look at the pop left. So when we want to remove the element from the left side, and then we just need to do pop left. So once we do this, so whatever the element that comes first, so that gets removed. In this case, it is apple. So let's clear this out and run it again. So now we can see that we got banana and 500. Two elements are there, but the first element from the left side that removed from the queue. So that's how we use the pop left. And let's look at remove. So when we want to remove the occurrence of the any item from the deque data structure, and then we use remove. So let's go here, and let's say I want to remove this banana element, and then I can just use the remove method. Let's come here, just replace this with remove method and then give banana. So let's say we have two bananas here, and then it will delete only one banana, that is from the first occurrence. Let's run it. So now we can see that we got the first element got deleted, that is the first occurrence of that element, and then we have the one more occurrence of the element. So and it did return nothing. So that's how this remove method works. Let's clear this out and go back to readme. Clear. So when we want to delete all the elements from the queue or all the elements from the deque, then we just use clear. So we don't need to pass any parameters here. So just remove that and remove this print statement. Okay, let's use that as well. Let's run it. So when we run it, we can see that the deque is empty and it did return nothing. So that is none when we use this clear. So this is how we use the clear method. So let's go to readme and look at other methods as well. So let's say we want to copy, we want to do a shallow copy, and then we can use this dot copy method on the deque, so that it will have a copy of the objects. So let's go to playground and look at that deque, and then copy deque. And let's do some operations on copy deque. Copy deque dot append it's me, and let's open the terminal and run the playground. So now we can see that this is the first queue, that is the print statement. So that is the original queue, and the second print statement we have the copied queue. So that's there. We have added the one more element to it, that it's me, and it's there. So that's how we use copy method. So let's go to readme again and count number of elements equals to the item. So count method takes an element and it counts the number of occurrences. So let's give, so here we have two banana, and then let's use count method, count. We just need to give the item. So that is banana, and let's remove this. Okay, so now let's run it, clear this out, and Python playground.py. So once we run it, it just counts it. Oh, we missed n here. So now we can see that we have two occurrences of banana element. So that's how we use count method. Let's go back to readme. So yeah, let's look at index method. So index method takes an item and just returns the position of the item. So let's go back to playground and use, just replace count with index, and find the index for banana. So let's run it, clear this out, and Python playground.py, and when we run it, so we got one. So this is the index of the banana. So that's how we use the index to find the index of the element. So let's go here and reverse the items of the deque. So when we use the reverse method, so it just reverses the elements in the deque. So let's use that. Just replace this with reverse, and it didn't take any params. And let's clear this out, run python playground.py. So once we run it, we can see that the deque is reversed. So the first element here we have apple, and that is the last element. And then at index number 3, we have the banana, and currently that is at index number 1. So, sorry, this is index 2. Yeah, it is index 1 now. So that's how we use the reverse method to reverse the elements in a deque. So let's look at rotate n number of elements. So let's say we want to rotate these two elements uh, to the right, and then now we should get uh, so when we rotate it, so we will be having these two at first. So let's try that. Rotate. Okay, for simplicity, just use 1, 2, 3. 1, 2, 3, and 4. We have okay, let's use one more element. We have 5 elements. So let's rotate 2 elements. So let's clear this out and run python playground. So once we run it, so we can see that it did rotate the last 2 elements, and now we have 4, 5, and 1, 2, 3. So that's how we use the rotate to rotate the elements from the right to left. So let's look at the one more method, that is max. Oh, that is not a method, that's an attribute. So when we use max length, and then it just gives the deque size. Let's clear this out. Yeah, I missed this one. So let's say we want to do rotation on right side. Let's say we want to rotate only these 1 and 2, and then we just need to give a negative number here. So when we use a negative number, it rotates the deque from the right side. So let's run it. So now we can see that we got these 2 elements to the right. So that is this 3, 4, 5, and 1, 2. So let's say we want to get the maximum size. That is this one, max length, the attribute on deque. So let's remove that and clear this out and run it. Okay, so looks like we didn't have any max size on the deque. So maybe here we can give this max length. So the max length is 3, and let's try to run it. So now here we can see that we got only 3, and we can also see that the first 2 elements got removed from it. So that's how we use this max length to use the storage limit. So though we have 5 elements in here, so it just we only have the last 3 elements, that is 3, 4, 5, and here we have max length of 3. So that's how we use the max length. Let's start with the chain maps. So let's look at the definition. So it's a declare class for creating single view for multiple mappings. So let's go there. So ChainMap combines multiple dictionaries into one. So let's say we have D1, D2, D3, and so on. So we can just combine all those dictionaries into one. So instead of using um, multiple, let's say we are trying to find the a key which exists in D1, D2, D3. So one of the dictionary has it. So we just want to find it out. In such cases, like we just combine all these 3 dictionaries into one and create a chain map and use operations on it. So let me copy that and show you how we can do it. So let's remove this one and print chain map. Open terminal clear this out and run python playground.py. So now here we can see that we created a mapping object. So let's look at the code. First, we are importing that chain map from collections. So that is at line number 1, from collections import chain map. And then we have the dictionary objects, that is D1, D2, D3. And at line number 7, we are creating a chain map object by using chain map class. So that is this. And we are passing D1, D2, D3 as parameters. So we can pass any number of parameters as we want. And at line number 8, we are just printing it. So let's say I want to find key D chainmaps.get. So as it's kind of wrapper on the dictionary, so it has all the methods that we can access on dictionaries. So we can also access that on chain maps as well. So let's use t.get d and print it. So clear this out, python playground.py. So now we got 4. That's because we have for key D we have the value 4. So that's how we use the chain map to get. Let's say I want to get element from D1. So that is dictionary 1. So let's use A here and run it again. So now we can see that we got 1. So instead of using D1 dot get A, D2 dot get A, D3 dot get A. So we are just creating we are combining all these dictionaries into one and accessing element on it. So we can access other methods as well, like items, keys, etc. Let's look at the methods of ChainMap. So let's start with this maps. So it's an attribute. So let's go here and remove this print statement and assign result equals to ChainMap. Oops. ChainMap dot maps. So when we use it, it just returns all the mappings of chain map. So let's print result and save it. So once we save it, let's run the python playground.py. So here we can see that we have all the mappings, that is D1, D2, D3. So that is D1, D2, D3. So when we compare it, so we have all these mappings. So when we use dot maps, it just returns all the mappings from the chain map. So let's go back to readme again and look at parents. So when we use parents, it returns all the mappings as a new chain map. It just skips the first one. So let's try that and see if it works. Chain map dot parents. Yeah. So let's look at that. Clear this out and run python playground. So now we can see that we got only D2 and D3. So those are the parents of D1. So it just skipped the first one and it returned the other two as a new chain map object. So that's how we use the parents. So let's say when we want to add a new child to the chain map, and then we can use a new child. So it returns a new chain map with a new mapping followed by all the mappings from the current chain map. So let's try that out. New child. So let's create a D4. So let's remove this and D4 equals to name John. Let's append this to, oh, oops, we need to add quotes here as well. So now we have D4 result equals to chain map dot new underscore child. We need to give the element here. So that is D4, the new mapping. And we are storing that in a result variable. And let's clear this out and run python playground.py. So now we can see that we got D4, D1, D2, D3. So that's how we add a new child mapping to the existing mapping. So let's look at the child map, whether it's actually updating the current child map or not. So that is, let's print chain map as well, child map. So let's clear this out and run it. So now we can see that the chain map that we have that has the only 3, that is D1, D2, D3. But whatever the result that we have D1, D2, D3 and D4. So it means that when we use this new child map, it's just creating a new child map and returning it. So if we want to override this child map, and then we just need to give instead of result, we just need to give a child map here. So it just updates the a variable to a new child map. So that's it. So now we can see that we got all the four in the variable child map. Sorry, child map. So let's go back to README and look at the other uh, yeah. So updates the first mapping in the chain map with the key value pairs from the provided mappings. So when we use this update, and if we pass the new mappings, and then it just updates the all the keys and values from the what are the mapping that we are passing to the uh, existing chain map. So let's try that. Go to playground, and so let's update T4. So it just updates the first mapping, that is T1. Let's try that out. Um, let's let's clear this out and Python playground.py. So when we run it, oh, oops, it did return none. That's because we are updating it here. So let's run it, Python playground. So now we can see that at D1 we have a new key, that is name. So it's updating the first one. So though we have D1, D2, D3, so it just updated the first one. So that's how this update works. And we have clear. So when we use this method, it just removes the all the mappings from the chain map. So let's try that. Chain map.clear. It didn't take any parameters. So let's remove D4 from it. So now we have that, and let's try it out. So Python playground.py. So once we run it, we can see that the chain map is empty. The first mapping from the chain map. So it just cleared all the keys and values from the first mapping. So that's how the clear works. We have copy, so it just creates a shallow copy of chain map. So try that. Copy, and let's add this to result, and add one more item to result. Result equals result dot update D4. So let's print chain map. And use result here. Clear this out, run Python playground. So now we can see that. So the first chain map that we have, the first map that we have A, B as keys. And if you look at the second chain map, we have A, B, and name. So it means it just copied the chain map to a new chain map. Yeah, so that's how we use the copy method to copy the object. So let's look at the one more method, that is get. So it just works like the normal dictionary. So when we use this, let's remove all this stuff, and okay, let's also remove this one. Let's use this chain map variable here, chain map dot get e. So when we run it, we just got the actual value of it. So let's say the key is not exist, and then we get none value. So you can see that none. So if you want to provide any default value, so it just give 1 2 3 4 1 2 3. So now we got 1 2 3. So it just works like a normal dictionary. So yeah, let's go to readme, and keys, values, pop item. So let's try that. Okay, when we do dot keys, it just returns all the keys from the mapping. Python playground. So now we can see that we got all the keys. Yeah, looks like it did return a keys view. of object. So let's convert that to a list using built-in list function. So let's clear this out and run python playground.py. So now we can see that we got all the keys from it. So similarly, if we use items, and then we will get a tuple of all the values, and if we use the values, we just get the values of it. So let's try that out. So we can see that we got all the values. And what are the other methods we have? Keys, system values. Yeah, we have pop and pop item. So let's go and try that out as well. So let's say I want to pop uh, key A from it, and if we run it, so let's remove this stuff and this one. So now we are using pop on ChainMap, and let's run it. So we got one. So when we do a pop, it just removes the key and returns it. So let's use one more print statement here, print ChainMap object. So once we oops, yeah, so let's run it again. So now we can see that for the first chain map, that is D1, we got only one key, though we have two keys at the definition here at line number 3. So we just remove the key A from it. So let's look at pop item. So let's use pop item. So it didn't take any params here. So it just pops one item from the chain map. So let's clear all this and run it. So now we can see that it just removed the one of the item from the chain map and returned it. So here we can see that pop item, yeah. So here we can see that the value B is removed from the D1. So let's try that one more time. Yeah. So it just works. So looks like we covered all the methods from the chain map. So just to keep the video short, so let's look at the other data structures of collections in next video. So if you find this is useful to you, and then like the video, share it with your friends, and don't forget to subscribe to my channel. Thank you.